instructions too, like how exactly one can proceed with respect to implementation of it. Uh, so now next problem would be what? Now think of this, like though I'm not talking about carrying out this further with respect to other system programs, but let us think of this. Suppose my object code is ready with my assembler, whether I'm using one pass assembler or two pass assembler, let me not worry about. Okay, but suppose my object code is ready. What are the object code format that was generated through my program? If it is ready, then what to do next? Now next thing would be what? Either you try to execute it or you try to like keep it there only. Only two options. So if you want to keep it only, then how will you know that what are the code that you wrote is getting executed or not? So from translation perspective, the way that we saw in our earlier sessions, like when instructions are given, you are only translating them to object code and you are done. You never worried about like what happens with that object code. Okay, even if you recall, we talked about one sample class where we took, I gave you 5, 6 instructions or 10 instructions, and I asked you, can you tell me what are the instructions that are that are there for the respective code? For the instruction object code and for the object code, the instructions, two-way. Right, then you did what? You took help of Intel manual and you somehow reached to the conclusion by saying that, okay, these are the instructions. But now if I talk about my own assembler, which is implemented by me with either of the mechanism, whether it is one pass or two pass, let me not worry about much. Okay, what happens next? So like my assembler in this case, I'm assuming that it is not containing any macro at all. Now what happens if macro is there? That's what I would be really talking in today's session. Now you must have seen like when you really work with assembler or the implementation, or even if you as a user see that, okay, if I use a C code where I'm making use of some macros, predefined macros or the macros added by me. So let us write the code and let us see how exactly the macro can be added. So macro 27.8 dot ASM. Okay, and how you write macro? So let me do this. Def percent macro. Okay, you write percent macro for a while. Then you give name, suppose my macro, and you give count here. Say 2 number of arguments that you would be having for this macro. Fine. And then now you start writing this instruction. So move ex comma. Now you want to give value of first argument. You write %1. Move ebx comma %2. XOR ECX comma ECX. Add ECX comma EX. Fine. And then add ECX comma EBX. And then you write here % end macro. Fine. So this is how your macro is comprised of. So you have this as a block. Correct. Generally in procedures, you do see something called as block. Now in our C code, rather, if we at all we write code, it is the block would be identified by this curly pair of curly brackets. Right? Opening and closing wherever you are adding. Similarly, for macro, it would be like this. Now, how exactly you will write the code? So you say section dot text global main. Now you call say move ESI comma 10, move EDI comma 20. My macro. Now you pass your parameters ESI, EDI. Fine. And let us say we display this. So let me add section dot data mhg db addition is %d comma 10 comma 0. Fine. So now we know that addition would be in ESI, correct? Because we need to pass it on. So move EX comma ECX for the sake of, because EX is containing, we want that result to be generated. So EX would be containing the sum. Fine. That means in this case, my ESI would be. So I will let you know what exactly they are called as. So you write push ESI, push MHG, call printf, add ESP comma 8. Right? Done. So now we know that we passed what values 10 and 20. So let me do other way around as well. If I don't pass values, I don't pass through registers, but suppose I pass it through 80 comma 40. Fine. So I have two results. One is 30, which is sum of these, with assumption that program would be getting executed rightly, and this would be 120. So let us see. Okay, so let me type nasm-f elf32 macro. Let us hope that there is no error. Oh, so we forgot to add extern. Because we want to use printf library function. Nasm gcc macro underscore 27.o dash m32. Now if you see, my code is shown as addition is 10, addition is 10. Let us go above. Okay, in the code, and let us see what is the change. So now if you see, in this case, we are saying that our assumption was what? I am passing here ESI EDI. So that's why result is stored in ESI. But here ESI is the actual parameter that I'm passing, and result is stored in EX. This ES and EX never matches. So in that case, I have to write it like this. Then only it will work. Right? Now let us see whether it is showing us these results. Nasm GCC. Now done. Now why? Because now you recall, like when you are taught C programming functions, then you talk about, okay, what are the actual parameters? What are the what is the other term that you use? Actual and formal parameters. Can you recall that? Yes, in C language, you must have seen what is formal parameter, by the way, in C language. Sneha, what is formal parameters? Vaibhav, Bhushan, Hemant, any idea? Whenever you use a function call, the variables that you pass when a function call is given, what you call those parameters as? Om, what you call those parameters as when you give a C function call with the parameters mentioned there?
Actual.
They may be replaced later, correct?
So when we call a function in C, so we call that parameter as actual parameter,
Okay.
and
And
while defining a function, we call it as a formal parameter.
formal parameter. Okay. Okay. So with assumption, okay, let us assume that whatever Om said is correct. Now what I will call here is, so in macros, these are called as positional parameters, because see, they are identified by the position. Now suppose if I don't want to mention ESI here, and if I say instead of 2, I am saying 3, and here I say I will make it here as EDX, sorry, EDI. I will make it as EDX, and here I will let ESI. Then my problem is solved. So instead of ESI, now here I will say %3. So this is a position that I am talking about. Let us try to execute this code. Nasm GCC. So what are the %3 that I am referring to? Now see what happens is, this is our source code. This is our source code, which contains a macro. But we exactly know that there is preprocessor 2. So what happens with preprocessor? Let us see. Now this should be replaced by these instructions directly. And wherever %1 is, this %1 should be occupied by EDX, %2 should be occupied by EDI, and %3 should be given to ESI because of the positions that they are referring to. So positional parameters. Fine. So let me show you how that pre-processing can be seen. So dash E. So I am saying p.lst. Now see my code. Now it says there is a macro. Now I don't have that macro. My section starts here, section.data. Now here we had a line. Okay, now let me open. Now see this line. So if I press up arrow key, it is not permitting me, but down arrow key is working. Up arrow key is not permitting me to go up. So this is removed completely. It says line number 9+1. So probably I might have crossed this. Now I am saying section.data, section.data, MSG, section.text, global main, external printf main, move edx, 10, move edi, 20, and then I had a macro call, my macro edx, edi, esi. Now if I go above, see what is the macro call, move ex, %1. What is %1 here? EDX. Now you can see that. Move ex, EDX. Now second line is move ebx, %2. What is %2? EDI. So ebx, EDI, ebx, EDI. XOR ECX, CCX. This is the line as it is taken. Add ECX, EAX. Add ECX, EAX. Add ECX, EBX. Add ECX, EBX. Move %3 ECX. What is %3? Positional parameter. So third parameter ESI. So ESI is added there. So this is pre-processing done at this side, and then your regular call to printf. So this was call printf. Now if I go below, and if I reach to second call, now my second call is here. My macro 80, 40 ESI. Now you will see that this 80 was given, 40 was given. So it never worried about what is the type of that variable. Whatever it is only kind of find and replace what is happening with pre-processing in such case. You can see here, see 80 is added directly and 40 is added directly. Earlier we said that what we gave these values, that's why these values were replaced in %1, %2. 80 was replaced here with %1 and 40 was replaced with %2 was replaced with 40. Correct, that's what. And then %3 was replaced by ESI in this case. Correct? One can see here. So this is how your pre-processing is working. But then how exactly it is doing this? So now we can see that there are two calls given. This is first call, this second call. Now how exactly it handled this? So it definitely will require some kind of additional data structures apart from your regular data structures, because we cannot include this name there. Now let me make an error here in the code. Let us do that. Let us see whether the error is shown there or not. Now suppose in this MOV I am saying MAV. Fine. And let us do this. Now if I try to assemble it, it is going to give me error. Okay, because now even error is confusing. My macro defined here, what exactly it is, like 17.2, 17.3, 23.2, 17.2, 23.2, 23.3. It is difficult to find out where exactly the error is. So maybe you can see that this MAV is occurring here. But what about others? Are we able to really work out what exactly the error is trying to tell us? So if I try to avoid that, and if I try to pre-process, it will never show me an error. Now see this LST. This was our original code. This was our original code where we had MAV. Now what are the first call is there? Macro call. This is to be expanded now. Call is to be expanded. So mav ex, edx. Now you can see here. It added that instruction as it is. Same thing, it added this instruction as it is. Because find replace never talks about system, say syntax errors or some kind of errors that generally an assembler should give. it would be telling you only pre-processing times of errors. So if at all this facility is to be adopted by the preprocessor, how exactly it should proceed further. So you will require in this case now some other data structures. OK, now those data structures would be what? Those data structures would be new data structures which are to be used. OK, so let me give their names. So let us see what exactly the data structures would be. So my first data structure name is macro name table, which is called as MNT. Second data structure is it is somewhat similar to, like both of these are somewhat similar to your symbol table. OK, but some difference would be definitely there. Macro definition table. Now, how exactly it should be? So for that purpose, let me make use of Excel to demonstrate you that fact. Now, how will I handle this? So let us say if I have say data structure created. So that data structure would be, say for example, let me give this name. So this would be a data structure which would be having name as macro name table. Now we have to give titles to this, correct? Rather, we have to give column names to this. So let us say first is some identity. So let me say serial number. So you can say macro number, for example, macro number. OK, then secondly, you will have another column, another name. So now this would be only name. OK, so we will require number of arguments. Sorry. Number of arguments. Similarly, I will create another data structure here, which is macro definition table. OK, now this will be containing again information of what? Macro number. And this will contain now the definition. So number of bytes. So suppose like start position. So let us say now if I am going to save this as in a sequential manner. Correct, in a sequential manner. So this one, this one, this one. Suppose this line number 1, ln1. OK, then ln2. Sorry, it would be at next thing. I am assuming I am going to save this in an array point of view. OK, definitely it is a string kind of error, array of strings. OK, now these strings are really bigger. OK, macro number, then first line, second line, and then line 3. Now suppose my numbering starts from here. It starts at 0. So my lines actually start at 0. Sorry. Number of lines start at 0 and they end at say 2. 0, 1, 2. So what I will do, I will write in macro name table, I will write start, end. So even I may remove this. So I will keep adding these lines. So here I added line number 1. So line number 0. Line number 2, index number 1. Line number 3, index number 2, and so on. Now my first macro is done here. So this would be start 1. Suppose my macro number is 1. You can add macro name as well there. By the way, I forgot to add name. So name. So name of macro is say for example my macro. Number of arguments are say 1. OK, it starts at 0, ends at 2. OK, this would be the actual code written in your macro. Correct. Now if you see in my case how it would be, let me take that example. So how many lines are there in my example? What are the example that I demonstrated you? Let us see this. How many lines are there for my macro? 1, 2, 3, 4, 5, 6. So ultimately in my macro definition table, okay, available with me. So I will write ln4, ln5, ln6 because we had move ex comma %1, move ebx comma %2, xor ecx ecx, add ecx comma ex and so on. So you are going to write these lines here. So line number 1 means what? Your mov ex comma %1. Similarly, here next line would be there. So say for example move ebx comma %2 and so on. So you are going to write that code. So your thing would be what? 3, 4, 5. So where it ended, started at 1, 0, ended at 5. Now you have next array, next macro. Say for example 6, 7, 8, 9, 10. So this would be a contiguous manner. So it may not have same number. Huh? So suppose my second macro contains only two lines. So say xor ex comma ex and second line is xor ebx comma ebx. Now I know that now my second macro number is this one. It is name is your macro. Number of arguments are say 0. I may not have number because I'm not using either of them. And it starts at 6 and ends at 7. So how this is how my the tables would be populated. Macro name table, macro definition table. Now, like at least this, have you understood? Any question, please? At least this point, up to this point, any questions? Now I already gave you example of macro. Yes, any question, please? Are you with me, everyone? शिवदीप, स्नेहा, संकेत, रितिका, अक्षय, वैभव, भाऊसाहेब, देवेश, प्रथमेश, मधुर. Yes, please.
Yes, sir.
Any question?
Yes, sir.
Or understood it? Have you understood it?
Yes, sir.
Okay, so this is how your two data structures would be. One is macro definition, a macro name table and macro definition table. Now what happens? Suppose, let me say, if I have code like this, what are the code that we saw now before a while? Suppose my code looks like this. What I need to do when it reaches to that phase where it gets this. Now what you have to do is while you design this macro, you start from here, line number 1. Whenever you see %macro, pick that name, my macro. And that's what we have added on the other terminal. Okay, you must have seen that, correct? That okay, my macro is found. So let me add this as a screenshot so that I can show you from that angle too. Okay, so let us open it here. Okay, so this is how our definitions are. Fine, of the macro, and let us open chat. This is where code is. Fine. So let me for a while add it here. Okay. Now what I got is I started from this line number 1. So I got percent macro. Suddenly my pre-processing work starts. So what I need to do now? So I see my macro. Okay, good. Go here. Add my macro name. My macro. When I added this. Now we identified in our case how many parameters are there? So 3. So let us add it 3 here. Okay. Now start and end. Suddenly we need to shift here. How many instructions are there? 6. So we wrote those 6 instructions. 1, 0, 1, 2, 3, 4, 5. So these are all 6 instructions added. Fine. Then you will add this number. So it started at 0, ended at 5. Your first macro is done. Now let us assume that suppose you get another macro. Its name is your macro. Then you got it at number of arguments are 0. So let me even try doing it for you peoples to show that part. Okay, let me add that code for a while. Emacs macro name. Okay, 1 minute please. Let me make the changes in the code so that I can share that code directly with you. So your macro. Yes. Okay. So let me go to this code. Okay, so let me take a screenshot of this. So I'm removing that printf call for a while, only to demonstrate you this part. So this is my code which I'm adding here. See the chat box now again. Pictures. Okay, so let me remove this now from here. Let me take close. Yeah, sorry. So let me go to chat. Let me add another image. So now I got this image. Okay, now see this image. What I have here in this image? I have first macro, I have second macro. Now percent macro, your macro, I have not given any number. So 0. And I have written these instructions here and simply percent and macro. And if I see this code, I have added my macro and your macro. Now we are talking about adding this definition, correct? Over here. Now if I see, I got your macro. So let me write that name in a simplified manner, the way that it is written, your macro. Number of arguments are 0. That's what we saw. Number of arguments are 0. Correct. Then there are 2 instructions. So I'm assuming I'm going here. So I'm adding those 2 instructions here. So for example, my first instruction is move ex comma esi. Move ex comma esi. And my second instruction is move ebx comma edx. Move ebx comma edi. So this is how I added the entries for my macro. So correct for this macro. What are the macro definition I got? Your macro, number of arguments are 0. Now I want these addresses. So where we started? So okay, this is move by the way. So I added first line of that definition move ex comma esi here on the line number 6. sorry, location number 6 and this is location number 7. So this is a complete array. Okay, contiguous array of strings. So if every line demonstrate or talks about a string. Correct. So you have now starts number of arguments 0. We saw 0. Starts at 6, ends at 7, ends at 7. So this is how you are going to populate this. Understood now? Okay. So let me add screenshot of this too for you peoples. So this is my macro. So this definition table would be contiguous one. Huh? By the way, it is kind of array, though it is shown like this, but we have to assume, we have to see that it is a contiguous array. And this 0, 1, 2, 3 is telling me the location number or ID number or index number for a while. So this could be consecutive, like though I am trying to fit it into a window for you peoples for a while, but it would be kind of a matrix. Say for a while, you can assume that as a matrix, and every entry of a matrix is a string like this, an instruction. Fine. So you are going to add it here. So let us take shift print screen. So let me see. I can add, yeah. So I added a table for you. Please see that. Open it and see whether can you see the same on your end. Okay. Are you able to see this? So this is how your tables are. So this is what you are populating the tables. You are populating the tables. Now, what would be next? Like what are the code that we saw here? Okay, we saw what each call would be replaced by its definition. So for example, here we saw my macro. This my macro should be replaced it by the exact code. Similarly, your macro should be replaced. So in this case, we haven't added any parameter here, correct? Because we don't have any parameter at all there. So that's why you will write only simply your macro. My macro, your macro. My macro contains 3 parameters, so those are added. So when you execute this code for a while, so let me show you how it will look like. I don't mean to say execute, rather I should have said it as like let me assemble this code. Okay, I assume now my screen is visible to you. Fine. So let me show you this code. This was the code that I added over there. Fine. Now we want to expand this. So let us save this. Okay, and let us go with this. Now let us say less p.lst. Now see this code. Now wherever we saw first macro call, it is replaced by now 6 instructions. And this is your second macro. Move ex, esi, move ex, ed. You can compare. But then what about the names that we added? No information of them is kept. Correct. Even suppose I generate an LST. Correct. And if I see now this p.lst, which is not the this is actually the pre-processed version. You can see that. See how exactly it did. It added my macro. It replaced that by these 6 instructions. So it is knowing that now this, like what happened is, what we did was we added the definition part. We added the definition part. Second task comes when definition table and macro name table is populated. Second task comes in terms of expand the macro now. When you expand, ultimately all instructions included should be replaced appropriately by taking consideration into the positional parameters. And in NASM, the positional parameters are shown by %1, %2, and so on. Correct? Similarly, now what do you call this as? When you see my macro, you start adding the respective instructions by replacing the positional parameter. So this process is called as macro expansion. So first part is macro collection. So we collected the macro, we populated the data structures like macro name table and macro definition table. Then we entered into second phase of macro expansion. And after the expansion, if I remove this, after the expansion, I do see that my code is generated like this. No idea about where exactly my original instructions are. So it is written in some different form. Correct, but you can see 10 and 20 was passed as a parameter, then macro call was there. So these six instructions are six instructions are meant for macro 1 and these two instructions are meant for macro 2. No proof of whether have you used macros earlier in this code. Nothing is shown here. Nothing is shown here. That means what? When it enters into assembly process, because if I talk about designing a two-pass assembler, so pass 1 we know we are going to populate symbol table. Pass 2 we know that we are going to exactly generate the code. This is a two-pass assembler. But then whenever your assembler supports macros, then you add one more pass, call it as pass 0, which is a pre-processing, macro pre-processing. You have to add a preprocessor, macro preprocessor, but our task doesn't end here as in a macro preprocessing. But okay, we first tried what in the expansion, like before we created this executable, we started by adding the code or macro entries rather in appropriate tables. So suppose if you don't get macros, correct? Let me show you this code even. ls-ltr star.asm. So we wrote this code, which was not containing at all, say macro, correct? So if I write nasm -plf32 trial.asm -e, though we don't know what exactly or is it contain macro or not. So let us see this p.lst. We know that macro is not there, but still it will show you this part. So it is definitely carrying out this code, this processing. Pre-processing is always done because NASM itself is a macro assembler which supports macros. So any assembler which permits macros to be included and later a code can be translated to an object code, then such an assembler is called as macro assembler. Now, whenever macro assembler is to be defined or designed, first you separate out two tasks. One is macro assembler or macro processing, and second part is your actual code processing. In macro processing, in your actual code processing, you can have a two-pass assembler or one-pass assembler. So I'm taking NASM. So two-pass assembler. So pass 1 and pass 2. Now the pre-processing would be referred as pass 0 or 0th pass, which will have two stages, two things. One is macro definition phase. Now what we will be doing with that macro definition phase is we are going to create these entries in the pre-processing phase, first phase of macro pre-processing. So this is definition phase. Definition phase of macro will contain populating entries into two different tables. One is macro name table and second one is macro definition table. Now when we are done with this part of definition, next part comes is macro expansion. In path 0 we have two again sub passes. First pass is macro definition and second pass for macro processing is the definition part. The expansion phase. Now what happens with expansion? Now you start. So suppose if your code is like this. So you got first code, first macro, like you check move edx comma 10, move edx comma 20, my macro. Now we will try to see whether is my move part of my code? No. Macro name table? No. Is move part of my macro? No. Is my macro is part of my table? What are the table that we saw before a while? So let me show you. So it is comparing it here. Correct? It is comparing with here. So whenever it finds this, yes, I found. Now the expansion phase should start. Now in expansion phase, you will see how many arguments are there. So you will first find out in the code whether do I have 3 arguments there. So 1, 2, 3, because we have to match that digit 3 there. Correct? So it is matched. Now it, okay, where is the definition? So it goes to that array. Okay, from here. So it takes an index. Okay, go at 0. You have to end at 5. So it goes here. So it gets information. Move x comma %1. Now it knows what is to be replaced here as %1. If I have %1, what I should replace it with. So that information should be available with me. So at the same time, I will see the source code. Okay, and my source code says you have to add edx. So I will add that edx over here. Okay, by saying this, and I will add this line into my temporary expansion file. Temporary expansion file or temporary file assembly file, which would be having information about this code of pre-process output of pre-processing. And I will write move ex comma edx because my first instruction is my first argument is edx. That's why I will write move ex comma edx. Now my second line is yes, I will move further whether as it ended no. Move ebx comma %2. Now what is %2? So I got %2 as edi. So it will write move ebx comma edi in the temporary file at the time of expansion. It will start creating that file. Everything would be written after it. Correct? And so on. You will continue when you reach to this line. You will always going to compare whether have we reached to this endpoint. When it reaches there, it will come back here and it will start with now next phase of it got now your other definition called your macro. Again, it goes to the table. Okay, let us go to that table. I will go to this table. So it says, okay, is your available? Yes, I got your macro. Now your macro is received. Fine. Your macro is received. Now you see how many arguments are there. You see 0. Okay, so good. So there is no replacement. So it says, okay, what is the line number 6? So move ex comma esi. It wrote it into the temporary file. Similarly, same thing was done for your next line. Okay, next line. Now I don't have that. Okay, let me take this. Yeah. So it gets this move ebx comma edi. So it also added that line into the code, and that's how the expansion would be done. And rest of the code would be written as it is, whatever the way it was found. Okay, 1 minute, please hold. Okay, so this is how you would be doing that expansion. Any question with this? So what you have now, suppose you have this ASM. Okay, now let me go here. So suppose you have this, like you want to create a object code. So you have first file as suppose program.asm, which contains macro. So you are going to do what? You are going to add a temporary file which says program.i, and this would be expanded form. Whole code would be available. Only macro calls are replaced by macro definitions by appropriate replacements of the positional parameters. You got program.i, for example. Now, for your 2-pass assembler, you are going to take this as a sample file or as a source file. So you would be getting pass 1 here. Then you will follow pass 2. Okay, by populating respective document things, and then you are getting program.o. Okay, but our task doesn't end here. That's what I was trying to tell you earlier. Like if at all we have such kind of code available where you have only macros without labels, then it's okay. But what happens if there are labels included in the macro? So let me show you that part too. Okay, now how exactly it would be done? Let us see. Now I have a code written. Say for example, my code is this. So let us say Emacs. 1 minute. Let me share you the screen. Yeah. Now suppose my label contains this label. Okay, my macro contains a label, and if let us say I call this macro once. Okay, I call this macro once. Fine. So let us see the code. What is the code? Macro 27. So this is our code. Fine. So let me add it in comment window for you peoples. Okay, I have added that code for you people. So even let me add the source file too. Okay, now let us try to assemble this. NASM. Yeah, this is our code. So let us apply assembly process. NASM -f elf 32 macro 27 ASM. Now let me write this -e and let us see what happens in the P file. Let me give p.i for example. How that p.i will look like now? Now see here. It is showing that that label is added here. Because this was first macro. Sorry, here your first macro ended. These are the lines 1, 2, 3, 4, 5. Okay, these are the 5 lines replaced. Rather 6 because these are 4. So these are 1. This is first, then second, then third, fourth, fifth, sixth. Your macro ends here. First macro, correct? And then your second macro starts here. This is second macro. Now what if I call that macro twice? Now how will you do that? Now we will do this like. Now I'm changing the order only for simplicity to show you like how the changes. Okay. Now I change the code. Now let me try to assemble this or let me create a pre-processing version. Okay. Now let me show you what happened there. Now this is my first macro call. It ended here. So line number 1, 2, 3, 4, 5, 6. Okay, so first line was ex comma edx. Now in second macro call it is ex comma edi. Wherever edi was, it would be replaced by edx, and wherever edx is, it would be replaced by edi. That's what you can see here. But now you will see in the source code, LP was added twice. Correct. Now suppose if I don't add this -e, see the error. Actually, we wrote only once. Label we wrote only once. Correct. But what happened is it is taking it 2 times. Why? The reason being is it is simply find and replace. That's why it found it. It replaced it here like this. It found it. It replaced it. It kept LP as it is. Now you can see LP is occurring twice. That's why error was thrown, that label LP inconsistently redefined. Another case. Okay, let us first try to resolve this. Now, how will you come out of this error? So for that error, what is to be done is, now whenever you find that a macro contains a label and macro is called more than once, then what kind of treatment should be given? So some renaming criteria should be used. Now I'm introducing you how NASM takes care of that fact. So in NASM, you are supposed to write with the label %%. Now let us see what happens. If I try to assemble or with dash E, okay, and let me check this p dot I. Now you will see that my label LP is added with something as a prefix. Same case here. Earlier it was shown as LP only, correct? Now I can see that it is replaced by 4 and 5. Now if I remove this and generate my code, let me see that code. Obj. Okay, let us go with nm so that you can see what are the labels generated. Now see, these are the labels added there. Okay, now suppose if I don't call that macro twice, and if I don't call macro twice, then this is the case, correct? So let us remove this. I am calling that macro once only. Fine. And if I now try to translate this, and if I see the information, it shows me LP. Correct? Now what happens? Suppose now if my code contains another LP here in my code. This is my label in main code and the LP above is label in its code, macro code, correct? If I try to translate this now, again same error would be there. So if you see that you want to use same label name, which probably might be part of a macro, but how will I know that? Na? Because I might be using a macro which was defined by somebody else and I may not have macro definition at all. Because if it is available to me through library, then what the macro writer should do is every person who is writing the macro should make sure that he will add %% there. Now see, I kept only one macro call, correct? And I have this LP label as well. Let us see now how the treatment would be. Earlier it gave us error. Now see. Now if I talk about NM, now see what happened. My LP in macro is added with the prefix. So this is internal label renaming. In some case, like I cannot say that it is true, but for this, but some similar kind of terminology is available with linker, which we'll be talking about later. It is called as name mangling. Name mangling. You are renaming that label by some name. Okay, you are not using the name as it is. You are replacing that name by some other name, and you are going to keep that track of that information. What name I gave. So that's what this is the label name that it gave. So wherever LP is now, LP would be replaced in a macro by this. Now let us see like how it is correct. Suppose now let me replace this. Let me remove this. This is my code. I will remove this label 2 from here to demonstrate that part to you. So let me write here JZLP for example. Fine. Now let us see this. Let us assemble. Okay, let us generate -E for a while. So you can see LP and JZLP is added, correct? Can you see this? Fine. Now, if I go to my code again back, and if I add here %% at one place only. Now again see, let us see the problem. If I try to assemble, now it shows here LP with a prefix, and here it shows LP as it is. I wanted this LP to be replaced by these two, correct? So in that case, what is to be done? Everywhere, whenever you are using a label inside the macro, it should be prefixed with %% compulsorily. This is mandate made by NASM. So for if at all you are planning to design your own macro, then you have to follow similar kind of process. Now let me show you what happens. Now see here. It had JZ, this label and this label is matching now. Correct? Are you with me? So I'm adding two parts for you. How to add macros and how the labels are added. Fine. So I'm adding both the screenshots in the chat window. So you can refer them to understand what exactly I talked about. Any question, please? Okay, I assume like I'm teaching or communicating these things in front of some learned group. Might be, probably it may be the case that you must be knowing this, but as a part of syllabi, I need to cover this. Correct. So with a real-time case study, because this is how it is done. Otherwise, we can have finished this course by seeing the PPTs only. I wanted you to give actual glimpses of what happens at that side. And I hope I'm reaching to you peoples, though you are not asking any question to me. I'm assuming that you are getting whatever I'm trying to communicate to you. Okay. So this is how your macro pre-processing is done. So we already talked about what two important data structures. One is called as macro data definition table, and other one is called as macro name table. Both of them are used in macro definition phase whenever we are processing a macro. After macro definition phase is over, then you start creating a temporary file after processing, pre-processing. So I gave name for, to it as .i, but maybe like you can give some name to it as per your choice. So this would be containing the macro calls replaced by their expansion, by their definition. So that phase is called as macro expansion phase. And let me tell you, like if you see the same book which I referred earlier for you peoples, this contains a dedicated chapter for this also. Directives, then probably chapter 4. So by the way, you can skip this directive chapter. The reason behind is like new current assemblers do not have all those directives available. Yeah. So this chapter contains majorly this definition and expansion phase. So even like they have given a sample how exactly your macro definition table would be and how your expansion would be. Fine. Really good things are described there. So macro definition table as well as macro name table. Okay, and how the parameters would be, either they would be like, for example, like C code. You go by macro parameters by name. Okay, and parameter by position. Named parameters or positional parameters. So in some macros do provide named parameters. So if you write EX, then you have to use EX there. EX is binded. Correct. So that's how. So name parameters or named parameters, or you can call it as positional parameters. Fine. Okay, even we talked about labels, so it talks about recursive macro, which I'm not going to rather cover here, but that's what it says. This pass 0, which I was talking about, how exactly that expansion phase goes. So it says if it is macro, read entire macro definition and store in MDT. Okay, along with MNT. Fine, and then go to this. Then this is expansion. Fine, and then like if you see end macro, then stop. End of path 0. Then you again try to find whether you have another macro, go with it, expand it, then done. Correct. So it is to be done for every macro. So it gives an idea about how your MDT would be. So name, pointer, number of parameters, first line and last line. You can add it here only. Okay. And then MNT probably may consider name 1 where exactly it starts, name 2 exactly where it starts, name 3 exactly where it starts. So you can choose either of this structure or the structure I explained earlier. Okay, for the definition table and name table. And so we are not going to consider this remove and so on, but like additional things are given, but now most of them are replaced by new design aspects. But you can skip rest of the things. If at all you are interested, you can go. Nested macro is one another important thing, which let me show it in a group of say minutes so that we can finish the session earliest. Okay, so what this nested macro is, suppose in this macro, in my original macro, suppose if I write here macro name, macro call inside a macro call. How exactly it would be done? Now, how will you manage that populating the definition and expansion? Okay, so I will show you this first, and in next session we will be talking about how the definition table and macro name table needs to be managed. Now you see here, in between we got these instructions too. After that label, correct? So let me show you the code so that sorry. You can compare. See, it got JZ percent LP. This was JZ percent LP, correct? And then suddenly you got your macro. So your macro is move ex comma ESI, move x comma ESI, move EBX comma EDI, move EDX comma EDI. And then you had add ECX comma EBX, add ECX comma EBX, move %3 comma ECX, move ESI comma ECX. And that's how your code is. And then your code ended here because we commented that part. So this is kind of nested definition. I am saying nested definition. There can be nested calls too, or nested definitions too. Okay, so this is you are calling a macro inside a macro. So nested macro call. Okay, I'm not talking about recursion. Fine. Now, if at all, suppose let us say I have definition like this. I am adding it here. So macro nested macro definitions. So let us see whether it permits it or not. So what I did here, I added that macro definition inside one another macro definition. So how to work with this? Now you can see it actually handled it, but it says your macro. Now where is your macro? The code was not added here, correct? But if I go and remove this, then you see an error. Okay. You see an error there. So it assumed that this is a label. You are trying to do something which is you are not permitted. So this kind of definitions may or may not be permitted there directly. Right? But let us try to see whether can we correct this. We said your macro, but this your macro definition was not found. That's why it is giving an error. So if I keep this before this line. Okay, now let us see. Now let me see that dash E. Now see you see there. So these are two lines are added. So before you are calling a macro, like that's what you are taught in like most of the programming languages. Before you use a variable, make sure that it is defined prior to the first use. And that's what it is verifying over here. Because when we added it earlier, later, after the first use, then it kept it as it is. But definition was not shown here. It was not got replaced. But if you have that definition earlier prior, then when it reaches to the call, it adds that. Now where exactly the call was? Okay, so let me go here and check. Your call was here, correct? But you called your macro here, correct? So this EAX EDX is not considered. This was your EAX EDX. Okay, this was EBX comma your second parameter EDI, and then your label, correct? Then add, then JZ, and then after that your macro definition was. So that's why this your macro definition was replaced by MoveEX comma ESI, MoveEX comma EDI like this. Correct. So if a macro assembler permits you definition inside a definition, then if you are using that definition prior to that call, that definition should be given. If you are calling a macro inside a macro or some anywhere else, the macro should be defined before its call. That's what is important. Is that okay? Fine. So this is what I wanted to talk about. Like if at all we are supporting macros, then how exactly the macro support can be given.